Hello there, Mr. Sutton here, bringing you the IM3 Chapter 3 Quiz Extra Practice Number 2 solutions on reviewing complex numbers. There's a puzzle that goes along with this one, so let's take a look at that. So here's a look at the puzzle that goes along with this extra practice. This is one of the games I created. This is called the I Challenge. The idea here is we have a whole bunch of imaginary numbers, sort of expressions over on the left side, and you just need to figure out what the answer is and circle the correct letter. Now, this doesn't go A, B, C, D. The letters are all craziness because when you actually get all of these letters correctly circled, it should spell something out. Now, going down a little further to look at the very bottom of this puzzle, I also included a little guide just for reviewing how to work with exponents in general and imaginary numbers in particular. So remember, we're going to be adding exponents when we multiply the same base. We can subtract exponents when we're dividing bases. If we have a power to a power, we're really multiplying those together. And if you have a really big power of I, remember you can divide that by 4 and take the remainder and use the remainder instead of the original power. And then we just have to remember that I to the 0 is 1, I to the first is I squared is -1, and I to the third, it says here, is -I. All right, let's give this a shot. All right, so here's our opening problem. I to the 6th times I to the 7th, all of that raised to the third power. There's a lot of different orders you can do these in. Since any power of I that's 2 or higher can be simplified, you could always simplify before using your exponent rules, or exponent rules first, then simplify, or some combination. In this case, I'm just going to use my exponent rules, and then I'll do my remainder trick at the very end. So I to the 6th times I to the 7th, adding my exponents, that's going to be I to the 13th. And then I to the 13th to the third, now I'm going to be multiplying my exponents to get I to the 39. And dividing that by 4 to get my remainder, or just keep subtracting power multiples of 4 until you get something between 0 and 3. 36 is the biggest power multiple of 4 that goes into that. 39 minus 36 gives me 3. So my remainder is just I to the third. And then I to the third is really -I. So that allows me to pick choice C. And we'll just keep track of our choices that we picked down below here as we spell out the word or words that are the answer to this puzzle. All right, next up, we have a fraction going on here. Before I do any division, though, I'm just going to multiply the stuff in my numerator together. So we have I to the 2 plus 5, or I to the 7th up there. And now if I'm dividing, I'm really subtracting the exponents. So this is I to the 7 minus 3, or I to the 4th. I to the 4th is really just the same as I to the 0, which is just going to be 1. So if it's just 1, that means we're picking choice O, so we have a CO going on. For this next problem, I have a bunch of i's multiplied together, so I can just add all these exponents together. So we have 9 plus -6 is going to be 3, 3 plus 3 is 6, 6 plus 4 is 10, and 10 plus 2 is 12. So this is altogether going to be I to the 12th. Using my remainder trick, dividing this by 4, the remainder is going to be 0, and I to the 0 is just 1. So that's an N to go with our list of letters there. For this problem, I've got a fraction, I've got some multiplication, I've got some exponents. Let me first take care of the stuff inside this parentheses. I mean, I have to start somewhere. So I to the -7 times I to the first. Now, before I just start throwing reciprocals around, I'm going to see if these negatives take care of themselves on their own. So this would be I to the -6 inside that parentheses if I add those exponents together. And let me also do I to the 6th to the 7th power, so I'm multiplying the -6 and the 7 together. That gives me an I to the -42 in my numerator. I think it's time we started simplifying the denominator as well. So we're going to be adding these exponents down here. -3 and -5 gives us an I to the -8. And now if I'm dividing, I'm really subtracting. So this is I to the -42 minus -8. So that's really -42 plus 8, which is going to be -34. To deal with the -34, one trick you can use is just keep adding 4 or multiples of 4 until you get a positive exponent between 0 and 3. So one multiple of 4 that I could add to this that would help me would be, say, 36. So if I add 36 to that, then I can treat this as I to the second power, which we know is just -1. So that ends up being, let's see here, choice G. Now it's time to tackle this crazy looking expression. I'm going to deal with this fraction over here first. Since I'm dividing, I'm subtracting the exponents. So I've got -24 minus -50, which is really plus 50. So I'm basically doing 50 minus 24, which is 26. So I to the 26. I to the 68, I'm just going to leave that for a minute. And then I to the third to the 17, let's multiply those together. So that'll be 3 times 17 is going to be 51. Since I'm multiplying these i's, I can just add the exponents now. 26 plus 68, that's going to be 94. 94 plus 51, that's going to be 145. Feel free to use a calculator at any point for this number crunching. Let me use my remainder trick now. 144 is a multiple of 4. So if I subtract 144 from 145, I get a remainder of 1. And I to the first is just I. So that's going to be R. For this problem, we've got I to the 69 to the 85th. So right away I know I might have to multiply these exponents up here. But that would require a calculator. And I'm making it a personal challenge not to use one for as long as I can on this one. So I'm actually going to simplify I to the 69 by taking its remainder when I divide by 4. 68 is a multiple of 4 that's less than 69. 69 minus 68 gives me I to the first in there. And then for my denominator, I could go ahead and add those to get I to the, let's see here, that would be 79. All right, so now in the numerator, we have I to the first to the 85th. Still need to multiply those exponents, but this is much easier now. 1 times 85 is just 85, so no problems there. Dividing these i's, I'm subtracting the exponents. 85 minus 79 is going to be 6, so I to the 6. I have to go back and use my remainder trick again. Subtracting a 4 from this, we just get I to the second power, and then that's going to be -1. So I'm feeling pretty pleased with myself. Give me an A. Problem, we have some division and multiplication going on. So rather than messing around with the negative exponents, I'm just going to do regular exponent rules and hope that those take care of themselves. So I've got I to the 33rd divided by I to the -31. I'm going to subtract those exponents to do that division. So we have 33 minus -31, which really means plus 31. 33 plus 31 gives us 64. So I to the 64 is that first term there. For the next one, we have got, let's see here, -64 minus -31. So again, we're adding 31. This time, it's kind of like having 64 minus 31 and make the answer negative. So that's going to be -33, I to the -33 that we're dividing by. And then finally, we still have I to the 46. Okay, let's go through now and do these from left to right. So I've got 64 divided by -33. Again, I'm going to be subtracting the exponents. So this is going to be, I believe, 97 if I add those together. And then I'm going to have 97 plus 46. So let me think here. 97 plus 40 would be 137 plus another 6. We've got 143. So I to the 143 when all is said and done. So first subtracted those two exponents and then added those last two exponents to get 143. Okay, we still have a very large power of I, so I'm going to keep subtracting multiples of 4 or find the remainder dividing by 4. 140 is a multiple of 4. 143 minus 140 gives me 3, so we have a remainder 3 there, and I to the third is really negative I. So that means we've got choice T here, so I'm going to put a T at the end of my word here. So I have a feeling I know what this might spell, but let's keep going. For number 8, we have a whole bunch of i's inside this fourth power parentheses, and we have another thing kind of kicking around over here. So let's deal with the stuff in this first parentheses first. So I've got I to the 64 times I to the negative 24. So I've got to add those exponents. 64 plus negative 24 is going to be 40. And then I have 40 plus another negative 100. That's going to give me negative 60 in there. At this point, I'm going to apply those exponents that are outside the parentheses. So I have to multiply by the exponent inside to do this. Negative 60 times 4 gives me a negative 240 for that first power of I. And now we have 95 times 5. Well, 5 times 100 would be 500. So this is going to be 5 times 5 less than that. So 475 then for that power of I. Next up, I'm going to be adding my exponents again because I'm multiplying the i's. So that's going to be I to the 235. And now I'm just going to subtract powers of multiples of 4 until I get something between 0 and 3. So let's see here. 200 is definitely multiple 4. 235 minus 200 is 35. And then 32 is a multiple of 4. 35 minus 32 gives me 3 for the remainder, dividing by 4. I to the third is really negative I, and negative I goes with u for that one, so we have a u at the end there. On this next one, we have some fairly high powers of I involved in this fraction. I'm going to deal with my numerator first. So these i's being multiplied, I have to add the exponents. So 472 plus 91. Well, 472 plus 90 would give me 562. Add another one to that, I have 563. Next up, for these i's, since I'm dividing, I have to subtract the exponents. And since I'm subtracting a negative, I'm really doing 563 plus 313. So that's going to be, let's see here, we got 6, 7, 8, so 876 for the power of I. Now I'm just going to reduce this to something between 0 and 3 by doing my divide by 4 remainder trick. Now 800 is a multiple of 4, so this is really like having I to the 76. And 76 is actually also a multiple of 4, so there's no remainder here. This is just I to the 0. I to the 0 is 1, so that's going to give us L for that answer choice. For this one, we have some stuff going inside this parentheses with a negative 70 outside. I'm going to try to deal with the stuff inside here before I even think about that negative 70. So adding these together, because I'm multiplying the i's, so I have to add the exponents. This is going to be I to the negative 56, 5 plus negative 61. And then before I apply this negative 70, which I'm going to have to do before I can use this I out in front here, exponents before multiplying, I'm going to deal a little bit more with this I to the negative 56. So I'd like this to actually become a positive, or at least something between 0 and 3. And I'm allowed to just keep subtracting or adding multiples of 4 until I'm happy with my new exponent. Now 56 is a multiple of 4. So this is really the same as having I to the negative 56 plus 56. That would just be I to the 0. And this is kind of nice because now if I apply 70 out here, I have to just multiply it by the exponent inside. 0 times anything is still going to be 0. So I really have I times I to the 0. I to the 0 is just 1. This is just I to the first then, if I add these exponents together, if I do it that way. Either way, this just comes out to I. So that's going to be choice A, going at the end there. Number 11 is in the category of way harder looking than it actually is. I've got all of this stuff being raised to the 0 power. That's the key here. So remember that anything to the 0 is 1, at least anything except for 0. And none of these powers of I ever come out to 0. So we're guaranteed that we're raising something other than 0 to the 0 power. Well, that being the case, this whole thing then just has to come out to 1. So that's going to be T going with our choice of 1 down at the bottom here. For this problem, you could end up doing a lot more work than you need to if you start multiplying these exponents together, which is what you could do. 72 times negative 8 times negative 40 times 64. There is a craftier way to do this, though. So 72 is kind of a big power of I. I'm actually going to simplify that to something between 0 and 3 before I do any of this other craziness. So since 72 is a multiple of 4, if I take the remainder dividing by 4, this is really I to the 0 power. And now 0 times negative 8 times negative 40. Well, actually, we even simpler, I to the 0 is just 1, right? So 1 raised to anything is just 1. So this whole parentheses with exponents is all just a big 1. When all is said and done, really all that matters is this I squared that's out there. And then I squared is just negative 1. So that's going to give me choice I going down there. Number 13 is kind of similar to a problem we did earlier with a bunch of fractions being multiplied. So let's just go through, simplify each fraction by subtracting the exponents, and then we'll multiply whatever's left over. So we have 78 minus negative 83, so plus 83. That's going to be 161 for that exponent of I. For the next one, we have I to the negative 90 minus 12, so that's I to the negative 102. And finally, we have 80 minus 3 here, so that's 77 for that last one. And don't forget, we still have that 99th I over there on the end. All right, let me go through and start adding these together. So I have, because I'm multiplying the i's, I have to add the exponents. So we have 161 plus negative 102. That's going to be 59. So, and then 59 plus 77. Well, let me think here. I think that's going to be 136. And then 136 plus 99, that's going to be 245. Is that right? No. 235. 235. There we go. You could check it with a calculator, but I'm pretty confident about this. So now we have a big power of I. Let's find the remainder dividing by 4. 235, multiple of 4 less than that is 200. 235 minus 200 is 35, so this is really like I to the 35. And then 32 is another multiple of 4 I can subtract. 35 minus 32 gives me I to the 3rd, which we know is negative I. So that's going to be O going there. For this next one, there's a lot of ways to do this problem. One thing I notice right away is that I have an I to the 0. I'm just going to write that as a 1. So we have 1 times I to the 59. And then this divided by I to the negative 52, I might as well just move that whole thing into the denominator of that first fraction. So we have I to the 52 times I to the negative 52. So when the dust settles here, in our numerator, we have I to the 59. And then adding those exponents down there together gives us 0 for that power, which is kind of nice. Since I to the 0 is just 1, I to the 59 divided by that is just going to be I to the 59. Finding the remainder dividing by 4, 56 is a multiple of 4 that I can subtract from 59. So this is really I to the 3rd then, which is negative I. And that gives us an n. So we come at last to the final boss battle problem, number 15. Let's see what we can do with this one. We have a whole bunch of fractions inside a big fraction. So I'm going to deal with all these mini fractions first by subtracting their exponents, and then we'll deal with whatever's left over. So we have 35 plus 25 for this upper left fraction. That's going to be 60, I to the 60 there. And then here we have 38 minus 15, so that's I to the 23rd. Lower left, this is negative 87 plus 65, so that would be negative 22. And then finally we have negative 16 plus 37, subtracting negative 37. So that's going to be 21 for that one. All right, so now I'm going to deal with the numerator and denominator separately. I'm going to add the exponents since I'm multiplying the i's in both of those situations. So we have 60 plus 23. That's going to give me I to the 83rd in my numerator. And down below, we've got negative 22 plus 21. So that's just negative 1 down there. Now I'm going to subtract the exponents again since I'm back to division. So we have 83 minus negative 1 or plus 1 gives us I to the 84. Looking at multiples of 4 now, or division by 4, the remainder, this is going to be a remainder of 0. 84 is divisible by 4. And I to the 0 is 1. So that means we have exclamation mark as the final piece of this message. So our final answer then is congratulations, which doesn't really sound like great grammar, but maybe if you thought this was an S, they just threw that one in there to keep you honest.